All right, let's take a look at example 4. This is kind of a fun one because fun is relative, but this is better as an example than many other things we're doing because this is going to be a math example, and math translates better into logic than trying to use English and translate it into logic. So I think this one works out well. It does use a little bit of high school level geometry. If you need a little refresher on that, there'll be some resources linked in the resources page. I'm not creative with names. So in the resources page, we'll link to some stuff about this aspect of high school geometry, but it should be pretty straightforward, okay? Let's start. Assume that 0 is less than or equal to A, less than or equal to B, which is less than or equal to C. So no matter what else we do, A is less than or equal to B, B is less than or equal to C, and everything is greater than or equal to 0. All right? Now, let's make a couple of statements. All right? Statement R is that the triangle with sides A, B, and C is a right triangle. Our second statement, P, is that A squared plus B squared equals C squared. The rule from geometry is if R, then P, right? If it's a right triangle, then A squared plus B squared equals C squared. So we can say R implies P, right? Nothing extraordinary right there. What about the other way? Well, if we remember our law of cosines, it says 2 times A times B times the cosine of theta equals C squared. All right? Now, if theta equals 90 degrees, then the cosine of theta is 0. 2 times, doesn't matter what this is, anything times 0 is 0, which means if the cosine is 90, then A squared plus B squared equals C squared, according to the law of cosines. And we know that theta is 90 because it's a right triangle, right? So thanks to the law of cosines, we can also say that P implies R. If you recall, R implies P and then P implies R. This is the converse. So if the statement is true and the converse is true, forgot neither, then we can say that there is a double implication, that they're equal. So now that we have the statement and the converse, what about the contrapositive? Well, if you recall, the contrapositive for P implies Q is not Q implies P. So since our statement is R implies P, the contrapositive, not Q implies not P. So the contrapositive for our statement is going to be not P implies not R. So we would say if A squared plus B squared is not equal to C squared, then it is not a right triangle. I kind of shortened it because it's supposed to say, sides A, B, and C, but whatever. You get the idea. That is the contrapositive of our statement. If that's the contrapositive, then what is the inverse? Well, if you recall, the inverse is the flipping of the direction and the signs from the converse. Our converse is P implies R. So our inverse is going to be not R implies not P. That is, if it is not a right triangle, then A squared plus B squared is not equal to C squared. So hopefully this has taken those concepts of inverse, converse, and contrapositive and made them a little more concrete in an example where they're all true, right? So hopefully that makes it a little easier. If you have any questions, ask in the forums below.